All right, so we're going to be covering graphing piecewise functions next. So a function may follow different equations on different parts of its domain. These functions are called piecewise functions. So on here, they give us an example. So they want us to graph this piecewise function, and it is made up of 3 different equations. Okay, so the first one is f of x is equal to 3 for x is less than negative 2. Okay, so our domain is that x has to be less than negative 2 for this function. So I'm going to go ahead and highlight that on my graph. So if I look here, it's all this little section here. Let's pull it down a little bit. So it's all of this. So this graph is going to take up this space right here. I'm just sorting it all in, try not to miss any spots. And so I am going to make my table for that graph right here, f of x equals 3, right there. All right. And we have a second function. So our second function here is between negative 2 and 4. So here is negative 2 all the way up to 4. So right here. I apologize, this is a little messy, but I think that's good. And then the last one here, x is greater than 4. So here's 4. And all the numbers that are greater than 4 are this way. I'm going to show that here on my table. All right. You know what? I didn't highlight this section and this section. Sorry. All right. So then the first one says x is less than negative 2. So we're going to pick points that are less than negative 2. Okay. So here's a point now. It doesn't say equal to. So it is going to be an open circle here, and then it's all the numbers that are this way, okay? And we're going to pick a few of those points. So say we will start, I'm only gonna pick like 3 or 4 points. Let's do negative 4, negative 3, and negative 2. So I'm gonna erase that so I don't get it confused from my graph. And one more. So I said I was using negative 4, negative 3, and negative 2. Remember, we always put our x values in order from least to greatest, so that's why I started with negative 4. And then it tells you that your f of x is equal to 3 for this part. So all of these are just equal to 3. 3, 3, and 3. Okay. So when I make this graph, if I look, negative 4, 3, negative 3, 3, and then negative 2, because it has just the less than sign, it is not equal to, so I'm going to make an open circle here. And usually I like to circle this to remind me that I do need to make an open circle at that number. All right, so then from there, I'm just going to make a horizontal line because it is a constant function, and that's what it looks like. All right, the next section here is negative x plus 1 between negative 2 and 4. So I am going to have to use negative 2 and 4. I'll pick a few numbers in between. But because of the equal to signs, it does touch it. So I'm going to go ahead and make a box around them just to make sure that I remember to make a closed circle. Okay, and so numbers between negative 2 and 4, we have negative 2. I'm going to pick 0, and let's pick 2. Okay, then from there, we are going to plug in these numbers into this function, negative x plus 1. So when I plug in negative 2 instead of negative x plus 1, a negative and a negative make a positive, and 2 plus 1 gives us 3. And then I plug in 0, 0 plus 1 is 1. I plug in a positive 2 there, and it ends up turning to a negative because of this negative in the front. So negative 2 plus 1 is negative 1, and then last negative 4 plus 1 is going to give us negative 3. Alrighty, so then from there, let's see, what can I do? We're going to start with negative 2, 3. So negative 2 and 3 is right here. So what happens is we have an open circle here, but because of this other section of the graph, it gets filled in. Okay. And then here we have 0, 1, and then 2, negative 1, and then 4, negative 3, and also on 4, negative 3 should be a closed circle. I'm going to go ahead and connect my dots here. That's what my graph looks like. And my next section, now this one is 1/2 of x minus 5. That's my equation, and it's for x is greater than 4. So here we are going to start at 4, and we are going to put all the numbers that are greater than 4. I don't know why I put a box. I'm going to circle it just to remind me to put an open circle. So we're going to pick numbers that are greater than 4 to plug in here. So if I plug in, because we're taking half of 4, I'm going to pick even numbers. So 4, 6, and 8. Okay. You want to pick at least 3 points. So then from here, half of 4 gives me 2, and 2 minus 5 is negative 3. Okay, I'm going to plug in 6 next. Half of 6 is 3, and 3 minus 5 is negative 2. And then half of 8 is 4, and 4 minus 5 is negative 1. So I go ahead and plot those points. So 4, negative 3, that's going to be an open circle here. And then 6, negative 2, so 6, negative 2 would be right here. 8, negative 1, and then we're going to connect those points. So this is my piecewise function. It is made of different pieces of different graphs, and it's all put together. Okay, if you notice here, you're never going to have two closed circles together because then it wouldn't be a function. And so that's why you notice you have an open function here, and then it fills in that dot. Okay, so then they want us to state the domain. So domain does cover all your x values from left to right. It doesn't skip any, so it's going to be negative infinity to positive infinity. Remember, we're going to write this in interval notation. And then range, we see how low our graph goes. So for our range, this is the lowest that our graph actually goes. So it's going to be negative 3, and it is a closed circle there. So negative 3, comma, and then we see how high it goes. So the highest that it goes, it looks like it goes up to here. But if you notice this arrow here, that means it's going to forever go up. Okay, so it's going to be from negative 3 to infinity. All right, let's go ahead and try the next problem. Here we have 2x plus 5 for x is less than or equal to negative 1. Okay, so here we're going to write our table here, and then I'm going to go ahead and see which section of the graph I'm going to use. So here is negative 1, and then all the numbers that are less than are in this direction. Okay, so I have to pick numbers for my table that are less than negative 1, but also include negative 1. So I'm going to pick just 3 points. So let's go ahead and go negative 3, negative 2, and negative 1. So negative 3, negative 2, and negative 1. And because it does have the equal to sign there, I am going to box this to show that it is going to touch a negative 1. And we're going to go ahead and plug it into the graph. So then our function is 2x plus 5. So if I plug in negative 3 in there, so 2 times negative 3 is negative 6, plus 5 is negative 1. And then I go ahead and plug in the negative 2. So 2 times negative 2 is negative 4, plus 5 is a positive 1. And last 2 times negative 1 is negative 2, plus 5 gives you a positive 3. And I am going to graph it. So we have negative 3, negative 1. Then I have negative 2, 1. And then last I have negative 1 and 3. And because I have the box around it, I put that in the wrong spot. Or because of the equal to sign here, that means it's a closed circle here at 1, 3. And that's what your graph looks like. All right, the second section of the graph is a quadratic function. So it's a parabola, and it's going to be from negative 1, which is here, all the way to positive 1. So it's this tiny little section here where a graph is. I'm going to go ahead and highlight it, and my graph is going to go there. Here we have x squared, and then when we pick points, there's only 3 points really that we can pick, negative 1, 0, and 1. So my x value possibilities are negative 1, 0, and 1. Now on both of them, it's just the less than sign, so that means that we're going to have open circles here at this point and at this point. So when we plug in negative 1, so negative 1 squared is 1, 0 squared is 0, 1 squared is 1. So I'm going to graph that. So negative 1, 1, remember it's going to be an open circle. This one, it can be closed, and then this one is also an open circle. And remember, the reason it's an open circle is because it doesn't have the equal to signs here. And so it's going to look like a little parabola. And then last, we have the final section of the graph, okay? It's 2 for x is greater than or equal to 1. So here on my graph, Here's 1, and all the numbers that are greater than 1 are going to be on this side, okay? Now you have to stay within the boundaries. So this graph can't go into the other colors. It can't go into the purple section. It can't go into the pink section. It has to stay in its boundaries. So that's what makes it special about piecewise functions. Okay, and then this is f of x is equal to 2. So it doesn't matter what points we pick, the y value will always be 2. But when we pick the points, we need to make sure that we pick in the blue area. So this is -1, this is 2, and this is 3. So those are going to be the numbers that I use. Did I say -1? If I did, I really meant to say 1. So 1, 2, and 3. Okay, and then here at 1, it does tell you that x is greater than or equal to 1. So that means right here, we are going to have a closed circle. So here at 1, 2, which is right here, is a closed circle. And then at 2, it's going to be 2, and at 3, it's going to be 2. And our graph looks like this. Okay. And remember, it's okay. It's kind of like you teleport. Like your graph is going up, it's going up, it's going up, and then all of a sudden, it falls through this hole and reappears through here. And then our graph continues. And then it's like it falls through this hole and then automatically teleports to here and continues. So that's what these piecewise functions are like. Okay, our domain, we need to see which x values are covered. So you see your graph from here all the way to here. Now there is a hole here, but it is filled in up here because it teleports the same with this and it continues on forever. So for a domain, it's going to be -infinity all the way to +infinity. Okay, this one for our y values, we see how low our graph goes. And if we notice, there's an arrow over here. So that means it is going to go down all the way to -infinity. And we see how high our graph goes. So it goes up, 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 up. And our graph finally stops right here at 3. And it is a closed circle at 3. So we're going to use a bracket at 3. Okay, and the final example. So this one's a little bit more difficult because we are going to have to use transformations a little bit. Or we could just plug in, I think, but either or. I might do a little bit of both. So here we have -2x minus 1 for x is less than or equal to -2. Okay, so here, I'm going to go ahead and find -2. Here's -2. So this is a linear function. This section of the function will be in this area. Okay. And then remember when you're picking points, it has to start with, or not start, but it has to contain -2. And then you just pick 3 points. So I'm going to pick -4, -3, and -2. Okay, we go left to right. That's why I put -2 last. It is equal to, so I'm going to go ahead and box this to remind me that I'm going to make a closed circle on there. Okay, my function is -2x minus 1, so I'm going to go ahead and plug in -4, and that is going to give me 7. I'm going to plug in -3, that's going to give me 5, and I'm going to plug in -2, and that's going to give me 3. So I plot my points, -4, 7, and then -3, 5, -2, 3, and then that one is a closed circle. And then that's it. We connect our dots, and then there's that section of the graph. All right, the next section of the graph is the square root of 2 minus x between -2 and 2. So here's -2 all the way up to +2. So this next section of the graph will only stay in between these two lines. So we're going to start at -2. And then it's going to end at 2, so -2 and 2. And then you get to pick a few numbers in between. I'm just going to pick 0. And we go ahead and plug it into the equation. So it's the square root of 2 minus x. I probably didn't pick pretty numbers where we can take the square root, but it's fine. So -2. So when I plug in -2 to this one, 2 minus -2 would give us a square root of 4, which is just 2. 2 minus 0 is 0, and the square root of 2, I believe it's like 1.7. And last, 2 minus 2 is 0, and the square root of 0 is 0. Okay. I didn't put the boxes in the circle. So at -2, there's no equal to sign there. So I'm going to put a circle, an open circle on this one. And then here where it's equal to, I am going to make a closed circle. So I'm going to go ahead and graph this, -2, 2. It's an open circle. 0 and 1.7 would be about right here. And then 2, 0, this one's going to be a closed circle. And then something like this. Right, the last section of your graph. Here we have the square root of x minus 2 for x is greater than 2. So here I'm going to go ahead and shade everything from 2 and on. This is where my next section of my graph would go. And then it should be greater than 2, not equal to 2. So then it's going to be at 2. Whatever's at 2 is going to be an open circle. And then I pick a few points past 2, so 2, 3, and 4. And then the function is the square root of x minus 2. So I'm going to go ahead and plug it in. 2 minus 2 is 0, and the square root of 0 is 0. 3 minus 2 is 1, and the square root of 1 is 1. And last, 4 minus 2 is 2, and the square root of 2 is 1.7. So here at 2, 0, it's an open circle. 3, 1 is a closed circle, and then 4 and 1.7 would be something up here, and then it would continue on forever because it's all the numbers greater than. All right, so everything looks pretty good. So for our domain, we're going to see all the x values that it covers. So it goes from here. There's no gaps all the way across. It just goes straight to the left and to the right. So it's going to be negative infinity to positive infinity. On our range, we see how low our graph goes. So the lowest that our graph goes is here at 0. And it does touch at 0, so I'm going to use a bracket. And then it goes up. If you notice, there's like this open circle here, and then there's also this space between here and here that there's absolutely nothing on this side. But on this side, it's going to continue to slowly go up. Slowly, and it's going to go up and up and up and up. Okay? So that means that this graph, even though there's a gap here on the left side, it's already filled in by this side. So it's going to go up forever. So from 0 to infinity. All right, so that's it for the notes. Let's go ahead and look at your delta math just so you can see what to expect. So, all right, so this one's -5 to -1. I just want to show you guys how you guys are going to graph it on here. So first, we're going to go from -5 all the way to -1. Both of them are open circles. And of course, you would show your work on a separate sheet of paper. And you pick a few numbers in between. I'm just going to pick one number in between for the sake of the example. And then the same thing for the 2x minus 6, you're going to have to pick points between, it says -1 and 2. So -1, it is only a less than, so it's going to be an open circle all the way up to 2. And it is going to be a closed circle because it says equal to on there. And then we pick a number in between -1 and 2. Let's pick 0. Okay, so first for the x minus 4 function, we're going to have to plug in -5 minus 4 gives us -9. -3 minus 4 gives us -7, and -1 minus 4 gives us -5. Then next here, we have 2x minus 6. So we plug in 2 times -1 is -2 minus 6 is -8. And then 2 times 0 is 0 minus 6 is -6. And then 2 times 2 is 4, and 4 minus 6 is -2. Okay, so we're going to go ahead and graph this. So it's between -5 and -1. At -5, it's -9. So -5 and -9 is here. And then we're going to drag it all the way up to -1, -5. Okay, and so remember, it needs to be an open circle here at -5 and an open circle here at -1. Okay, the next piece of the graph is -1, -8, and 2, 2. So here, -1 is here, and -8 is all the way down here. So we're going to go from here, and then the other point, it has to go through 0, -6, and 2, 2. So I'm just going to click and drag all the way up to here. And then it is a closed circle up here at 2, -2, but it's an open circle here. We go ahead and submit our answer. Do you want to submit? Yes. And that is correct. Okay, so that's how you would do those problems. Let's go back. Let's do this section here. Let me go ahead and erase all of this. Wonder if there's a way just to erase it all. I have no clue. Okay, so this one mixes points and the linear functions. So let me just erase all of this. There we go. So here we have two functions, and then the first function is x minus 6, and it says x cannot equal 3. And then here it's 4 for x equals 3. So this is what we're going to do. We're going to graph x minus 6. So here our b is our, I'm doing mx plus b, y equals mx plus b. Oh, look, there's still all this stuff to erase. Hide cursor, focus. Sorry. But it's gonna bother me if it's there. Now you can plug in just like we were doing. Maybe I should do that better just so that we keep it consistent. Let me go ahead and do that instead. So it says it can be all the numbers except for 3. So I'm just gonna pick 2 points as long as it is not 3. So let's pick, I don't know, 5. Let's pick a negative number, -2, and let's pick a positive number, 3. We're going to plug it into x minus 6. So if we plug it in here, -2 minus 6 gives us -8, and here 3 minus 6 gives us -3. Okay, so then I'm going to go ahead and make my line. So at -2, it should be -8. So -2, -8, and at 3, it should be -3. And so there is my line, but it needs to be all the numbers. So what you do is you click these ends and it makes an open circle, but that's not what I want. I want the entire line. So it goes out that way. And then here, the same thing, I click, it makes an open circle. I click again and it makes the entire line. So it can be all of these except for when x is equal to 3. So I need to make an open circle on x is equal to 3. Okay, so then this next section here is when x is equal to 3. So I'm going to make a closed circle. When x is equal to 3, your y value is 4, which is right there. Let me go ahead and submit the answer. Do you want to submit? Yes. No. Alt-T. All right. So then the last section is going to be graph the piecewise functions given below. So here we have, ignore all of this. It's just too hard to erase it all. It's going to take too much time. So here, -3 for x is less than or equal to -6. And then here we have x, the absolute value of x for x is greater than 4. So it does have steps for you to follow here. So step 1, select the function, then move with the blue dot if necessary. Okay, so this is going to be a constant. The -3 is going to be a constant, which is going to be this line right here. So it's going to be a horizontal line going straight across. And because it says f of x equals -3, that means it needs to go straight across your y-axis at -3. Okay, so that's where it should be. So then you put done. Okay, now we need to put the boundaries on it. So here it says less than or equal to -6. So we're going to go ahead and push this all the way up to -6, and it's all the numbers that are less than. So these are the numbers that are less than on this side. It does have an equal to sign, so we don't have to change this little dot, and then we're going to click done. Now let's move to the next section. So this one is your absolute value function. So my absolute value function is this one. Okay, it does not have any translation. We don't have to move left, right, anything. Okay, it's going to stay right there. But my boundaries are x is greater than -4, greater than or equal to. So I'm done. I don't have to translate it, but I do need to put my boundaries on it. My boundaries are going to go from -4 all the way to infinity. So it'll stop there. And then it does equal 4, so I don't need to open that up. I click finished. And this is a start over button. Don't press that to submit. Click submit answer. Yes. Okay, let's try one more of these just in case. New problem. I actually like these ones. These ones are my favorite. Okay, so this is a x minus 4 between 0 and 3. So x minus 4 is a linear function. So we are going to need a line. X minus 4 is a line that is increasing. So it's going to be this one. And then minus 4 means that's my y-intercept. So we are moving it down 4. Okay, so that's what my graph looks like. I'm going to click done. Now let's set our boundary. So based off of here, it's going to be between 0 and 3. Okay, so between 0, here's 0 when x equals 0. And 3, I'm going to bring this all the way to 3. Oh, right there. And then we notice at 0, it's equal to, but not at 3. So 0, we can leave it as a closed circle, and at 3, we can open it up. Next, this is x, the absolute value of x minus 4. Sorry, I forgot to click done. Minus 2. So this is my absolute value function. So we're going to use this one. Now the minus 4 inside with the x is going to translate us 4 to the right. And then the minus 2 is going to move us down 1, 2 units. Okay, so now that I fixed my graph, I'm done. And then we're going to set the boundary. So it's x is greater than 3. So here I'm going to move it all the way up to 3. And then if you notice, it's not equal to 3. So we're going to go ahead and open up the circle. We click finished. Hopefully I did this correctly. We click not start over. No, I clicked start over. Don't do that. I don't know how many times I've done this when I'm practicing. Okay, negative 4. And then we're going to done. At least you get a little review. We set our boundaries. So our boundaries are from 0 to 3. So I take the blue arrows and I drag them. It's equal at 0. This one we're going to open up. Done. And then I take my absolute value function. The first thing I tell you guys not to do, don't press the red button. I go and I press it. It's going to go 4 to the right because it's minus 4. And then 2 down because it's minus 2. That's where it's at. Done. Now let's set our boundaries. It's x is greater than 3. So I find 3 on my x-axis and it's everything greater. So we're good. And then I need to open up the circle because it's greater than. And then we finished. And now I can submit my answer. Are you sure you want to submit? Yes. And that's it. If you guys have any questions, there's also help videos you guys can watch here. You guys can go